Hello and welcome to my channel. We're going to be working on General Chemistry Exam Review Part 2, Mole to Mass and Mass to Mole calculations. So the first question I have here is, what is the molar mass of lead 2 phosphate? Now, sometimes they might give you the molecular formula, so you don't have to worry. But in case they don't, you have to write it yourself. So for this one, lead is Pb, 2, so 2 plus. Phosphate is a polyatomic ion, so PO4, and then you have 3 negative. Next, crisscross. So this 2 goes over here, this goes over here. And then that would become PB3 in brackets PO4 2. Okay, so that is the formula for that lead 2 phosphate. Now to write the molar mass, start by writing out the individual elements involved. We have 3 lead, multiply that 3 by the mass of the lead. Lead has a mass from the periodic table, okay? So look for lead. Lead has a mass of 207.2. So that is what we're going to do. 207.2, then multiply that by 3. That would give us 621.6 grams per mole. Now, next, we have phosphorus. Now, this in brackets, this 2 affects everything in brackets. So that means you have two phosphorus. So the next step would then be to multiply that 2 by the mass of phosphorus. So you have 30.97 as the mass of phosphorus times 2. So 30.97 times 2 is going to give us 61.94. And that is again grams per mole. So molar mass has a unit of grams per mole. Now oxygen, originally we had 4 and then we had these 2. So what we're going to do is multiply the 4 by 2 and that will give us 8 oxygen. Okay, so we have 8 oxygen in that compound and then multiply that by the mass of oxygen, which is 16.00, and that's going to give us 128. So what we are going to do now is go ahead and sum them up. We have 128 plus 61.94 plus 621.6, and this is going to give us 811.54. Okay, so that would be the molar mass of Pb3 PO4 2. Okay. Now the next question I have here says, how many moles are in 31.7 grams of sulfur trioxide? Now sulfur trioxide is SO3. Again, in order to find moles to mass and mass to mole, we need this formula, which I'm going to show you. So if we use the triangular method, we have mass denoted as small letter m. So this is mass. Okay. Now here you have n. This n is number of moles. This is number of moles. And then over here you have big letter M, which is going to be the molar mass. So what this means is that if you are looking for mass, you're going to isolate the mass, right? Which means you're going to multiply n times n. If what you're looking for is N, for example, you're going to isolate the N, and therefore what you're going to be doing is divide mass by the molar mass. And that's what you're going to be doing for this. Okay, so we're going to divide mass by the molar mass, which means that the first thing we're going to do here is to find the molar mass of sulfur trioxide. So again, we have sulfur to be 1, multiply that by 32.06, which is the mass of sulfur. Then oxygen, you have 3 of them, multiply that by 16, and that is going to give you 48. And again, we add up. Sum them together. That will give us 80.06. So now that we have this molar mass, so this will be your molar mass, the big letter M, which is molar mass. Okay. N is equals to, remember N means number of moles, which is how many moles. So we're looking for moles. N will be equals to the mass over the molar mass. The mass here is given to us as 31.7 grams. Divide that by 80.06 grams per mole. Now remember, in maths, when you have a double division, this goes up. So instead of that, you're going to have it as times 1 mole. Okay, right? So per mole or times mole, as the case may be. Now note, these two guys will cancel out. So that's going to then give us 31.7 divided by 80.06. So that's going to give us a mole of 0.3. Again, significant figures very important. Since this is 3/6 week, leave your answer in 3/6 week. So it's going to be 0.396 mole. Okay, and that is it. All right, the next question I have here says, what is the mass of 3.4 mole of carbon dioxide? So carbon dioxide is CO2. Now again, using that triangle method, I'm going to draw it again. You can always do this each time just to help you. You have your small m on top. You have n on this side, and you have the big letter M. This time we're looking for the mass, which is this, okay? So which means I'm going to be multiplying my mole and the molar mass. So again, you have to start by calculating your molar mass. So the molar mass, I have carbon, 1 of them. So 1 times 12.01. The mass of carbon is 12.01. Oxygen is 16 multiplied by 2 because I have 2 oxygen. So this is 12.01. This is 32. Now add them together. This is going to be 44.01 grams per mole. So if we're looking for M, which is the mass, you would have it as 3.4 moles multiplied by 44.01 grams per mole. So remember, M will be equals to N times big letter M. So the moles will cancel out and you're left with grams, which is exactly what you're looking for. Now the unit for mass is grams, okay? The unit for molar mass is gram per mole, and the unit for number of moles is mole. So the moles cancel out and you're left with the grams, which is the unit for mass. So 3.4 multiplied by 44.01 is going to give us a 149. So since this is two significant figures, it would be best to leave your answer in two six-figure. So the original answer would have been 149.634, okay? But approximately your final answer would then be 150 grams, because you want this to be in two significant figures, unless your teacher does not care. But I know a lot of teachers do care about significant figures in these calculations. So this would be your final answer, 150 grams. Okay. All right. The next one, it says how many mole are in 5 liter of ammonia gas at STP? Now, at STP, STP means standard temperature and pressure. Okay. And in gas laws, you would usually use ideal gas law to solve this kind of question. But since we are doing mass to mole, we're not going to do that. Rather, I'm going to show you this. 1 mole of a gas is equals to 22.4 liters. So that's the conversion you will use at STP. You can also use gas law. You can actually use both. It doesn't matter. But for this particular calculation we're doing, we're going to use 1 mole equals 22.4 liters. That is the standard at STP. So now we're going to start. If you have 5 liters, and you want to convert it to mole, what do? You're going to multiply by 1 mole and then divide by 22.4 liters. You see what I did? You are doing it this way because you want the liters to cancel. You're converting to moles. Whatever you're looking for, the unknown will always be on top. Okay? The unknown will be on top. Now, for example, if this was 5 mole and they wanted us to look for what the volume would be at STP, what you would do is, so let's assume if this was 5 moles, that would then be times 22.4 liters over 1 mole. You see that? So the unknown will always be on top. So if this was the other way around, the liters will be on top because that's what you're looking for. But since for this particular one, we're looking for number of moles, the mole will be on top. And when you cancel out the liters, you're left with mole. So you have 5 divided by 22.4. So 5 times 1, then divided by 22.4. And that is going to give us a 0.2 moles. Now you might be wondering why I stopped at 2 moles, because you have only one significant figures given to you. So you want your answer to also be 1/6. Okay. But I always advise write out the full answer if possible, and then before you round up. So the full answer I would have written is long, but I could have just gone like up to 4, like 0.2232 before I round up, so that your teacher would see the efforts that you made. Okay, and you can get your full mark just in case. All right. Now the next question here says, how many molecules are there in 2 mole of oxygen gas? So oxygen gas is diatomic. So oxygen is diatomic and you have 2 of them. So it's going to be 2 times 16, which is going to be 32 grams per mole. Okay, so you're looking for the molar mass. So this one is molar mass that I just calculated. So now the word molecule is different from moles when it comes to calculation. Please take note. Avogadro's number is 1 mole equals 6.022 times 10 raised to the power of 23. This is Avogadro's number. And this can be atoms, it can be molecules, particles, it can be formula units. It can also be ions. Okay, these are the different forms that this question can be asked. They could ask how many particles, how many formula units, how many atoms, how many ions. If you're dealing with oxide, for example, if you're giving you like an ion, there might be like how many ions are there in 2 mole of calcium 2 plus, you know. So if they're giving you ions, they might ask ions also. So please note, when they ask this type of question, they are not asking, you're not going to be making use of the triangle equation. Okay, you're not going to be making use of and mass to mole, all of those. What you're going to make use of is the Avogadro's number, and this is the conversion that you need. Okay, this is the conversion that you need. So in this case, we don't actually need this. There are sometimes some cases where we need this, but for this calculation, we don't need this. We don't need it. So what you're going to do is just go ahead and start with your 2 moles. You only need this if this was given to you in grams, then you would use this to convert to moles before you solve, because the relationship is between moles and atoms or molecules and not grams. So if they give it to you in grams, then you have to convert to moles before you start solving. So for this one, it's already in moles, so we don't need this one. We don't need this. So all we just have to do now is go ahead and solve. You have 2 moles. Multiply that by the Avogadro's number. Remember, whatever you're looking for stays on top. So you will have 6.022 times 10 raised to the power of 23 molecules. Okay, 23 molecules. Then all over 1 mole. You see how that works? All over 1 moles. If what we are looking for was moles and they gave you molecules, it's going to be the other way around. Okay, the mole then stays on top while the Avogadro's number is under. That is, if these 2 moles were 2 molecules and they're asking for how many moles, then it's the other way around. So at this point, what I would do is cancel out the moles. So these moles we cancel, and then you multiply. So that's going to be 1.2 raised to the power of 24 molecules. So always remember, molecules and moles are not the same when it comes to these calculations. Okay, so that will be your answer. Now for the next one here, it says, how many atoms are in 22 grams of calcium? This is the one you have to convert to moles. So this time they didn't give you moles, and the relationship between atoms, that's the 1 mole equals to the Avogadro's number, has to do with moles, not grams. So the first step would be to convert. Since they gave you an element, the molar mass is the same as the mass in the periodic table. So calcium has a 40.08 grams as the molar mass, okay? So you just have 40.08 grams per mole for calcium. So to convert to N, the triangle method again. So this is where you make use of triangle method because you want to convert to the number of moles. So according to this, N, number of moles, will be equals to mass over the molar mass. So my mass is 22 grams. Divide that by 40.08 grams per mole again. So this is the same thing as saying times mole. So it doesn't matter. This is going to go up. So this here would cancel out the grams. And your N is going to then be 22 divided by 40.08. And that would give us 0.55. I want my answer in 2/6, right? Although this is not the final answer, so you can actually keep going until the end. So I'm just going to leave this in 3 significant figures for now. So now I have my moles, and then I'm going to start with the moles now. So 0.549 moles. Since I'm looking for atoms, I'm going to multiply this by Avogadro's number, 6.022 times 10 raised to the power of 23 atoms. over 1 moles. So this is the case where the atoms, the Avogadro's number stays on top. Okay, so these moles we cancel. And then you would have that to be times 6.022. And that would be 3.3. So now you can go with your 266 times 10 raised to the power of 23 atoms of calcium. So that's your final answer. So the first step, convert to mole, and then finally from moles to atoms. Okay. Next question here is this. It says, how many oxygen atoms are in calcium phosphate? So this question is straightforward. I put it here because I want you to see the difference. The one we just did before, it said how many atoms are in 22 grams of calcium. In this case, you must use the Avogadro's number to figure out the number of atoms by converting the grams to moles and then converting the moles to atom, right? But in this case, there is no number given to you, nothing. They are only asking you how many physical oxygen atom can you see in this compound. So this is different from that other one. It can create a lot of confusion for students, and that is why I put it in these questions. So all you just have to do is count the number of oxygen present. You only have oxygen here, and originally there are 4 of them, but then you have these 2. So you're going to do 4 times 2, which means you have 8 oxygen atoms present in that compound. Okay, so there are 8 oxygen atoms present, and that is how you answer that question. Okay, so I'm going to stop this here and try and put up a couple more questions that you can possibly see in your coming exams. I hope you found this helpful, and see you in my next video. Bye.